G'day. This is my fourth video in my series about creating a network probe on an Esp32 microcontroller. At the end of the last video, I ran into two problems. I was running short on heap memory and getting memory allocation errors, and also I was seeing excessive web service delays while my Bing code was blocking asyncio from giving time to the microDot web server. In this video, I look to try and fix some of those problems. Also, I'll walk through setting up a mpy-cross precompiler to precompile some of my larger micropython modules. And finally, I'll try and get the main web services in place so I can swap to development of the web front end that uses Angular. They'll be in video 5.
So I need to put together the micropython module compiler mpy-cross. So I'm following instructions that Fakir Maker on YouTube had. These are the instructions here. I'm really starting from the step 4. And just one note here, I found first time I tried to do this it didn't quite work, so let's try again. But I think my alias for where the mpy-cross actually gets created has another level that's under a build directory, but we'll run through, have a look at, see how this works. So just a note here, the Ubuntu instance I'm using is one that I have on my Synology NAS. So under the virtual machine manager, I already had a virtual machine set up with Ubuntu on it, so that turned out to be a easy way to get access to an Ubuntu server. The other nice thing about doing it on a virtual machine is you can have snapshots and roll it back if you make a bad mistake on the machine. Want to get back to a previous version, which I found handy one or two spots when I was doing this. So first we need to install the required packages. Some of these steps I'm going to speed up the video because they take a while. So if you see things whizzing by, it's just the video speed's been increased. So that's all the prerequisites installed. I'm going to now install the Esp32 tool change. And for this I found this step C and D take, or C and E take quite a while. Now we do step 5E. I just set up a alias for the environment. I'll use nano for that. So I started a new SSH session just so I get the alias info applied. And I'm starting on step 6. So this time I'm going to bring down micropython. So this is where I saw a difference from Fakir's original instructions. So under mpy-cross there's now a build directory. And you can see under the build directory that's where mpy-cross was built to or made. So I use that in my alias. So let's go back into Nano and add this alias, and again this is different from what Fakir had in his instructions. I can just think between when he put his instructions together and now they've now had mpy-cross built to this build directory. So again, I'll start a new session. So test this out. At the moment, I don't have any Python files there, so let's just make a temporary one. So now we see a test pi there, and if we do a mpy-cross on test.py, now do an alias, we see we've got a test.mpy, so that's the test.py compiled to a bytecode version of mpy. And that's what I'm going to do with some of the large modules in netProbe to save heap spaces, precompile them, and then just use the mpy versions. Okay, let's see if we use mpy versions of the modules, the precompiled versions of the modules, whether it improves how memory is being used. So you can see here in lib, I've now got my 3 large libraries or modules compiled up as mpy files. And one other thing I did down in main, just after it's imported all the modules, I've got a micropython.mem info equals true, which will do a heap dump. I also did this when I was using the py version of the modules as well, so I can get a bit before and after. So let's run this and see what it looks like. There's our dump. And everything's still working, so that's good. But let's look at our dump here, and I actually took a copy of this, and I have a copy of this dump from the same place in the version that didn't use the mpy files, that just used the py files modules. And so this is a comparison in Notepad++. You'll notice over this side, this is the py version. I couldn't work out how to get it to the other side. This is the py version, so this is the before, and this is the after over here. So the most noticeable thing is the maximum free size has gone to 2098 blocks. It was 633 blocks, and a block in the heap is 16 bytes, so that's equivalent to about 10,000 bytes, and this has gone up to about 30,000 bytes, which is a good sign. And you can sort of see in the heap management here, it's a lot longer than the before, and you see down the end of here it just says 2 lines free, whereas down here in the new version it has 32 lines free of free heap. So just a lot more heap available that is not fragmented, which is kind of what I was aiming for. The other test we can do here to see if things are working better is just at the beginning of main. Let's get that onto the device. I've moved the import of microDot async to the end of the imports, and if you saw in the end of the last video when I did that before, it'd get a memory allocation error. It just didn't have enough free area in the heap to be able to do the import of the microDot async. So let's try this again and run it. That's a good sign. Looks like everything's working. So that's one optimization I'll keep, is the use of MPY files for the large libraries. I think I'll just do these 3 libraries because things are working okay at the moment. I looked at some of these other semi-library things I've got, like the uping and the uweb page, but none of those are that large anyway. So if I'm really getting squeezed for memory or heap space, I could do the same to those, but I think I'll just leave it like this for now. So the other big problem we saw at the end of the last video was the way asyncio sort of simulates multitasking on this microcontroller. You don't really have multitasking, at least it doesn't have an operating system that supports multitasking. So what asyncio really does is releases control from processes so other processes can get a look in. And that works well if all the processes don't run for very long. But in this netProbe, what happens is microDot's processing and receiving web requests, and then the scheduler is doing the actual network tests, and that runs in the background. And what it does is runs through a ping, a Bing, and a web test for a single host. And then it does one of these await asyncio sleep for 20 seconds, and then during that sleep period, microDot's getting a look in to see what web requests there are, and then releases control back to the scheduler again. And that works fairly well. The microDot response time is really dependent on how long it has to wait until the scheduler releases control so it can make use of the sleep period. The problem is this Bing routine in the middle of the scheduler can take up to 25 seconds. So basically it locks out microDot for 25 seconds on one of these iterations. If it's doing a Bing and then a request comes in just as the Bing started, microDot's not going to get a chance to have a look at that web request and do anything with it until the Bing's finished, the web test is finished, and it goes back into another async IO sleep so that microDot can get work done. So we're going to have to look to see if there's a way of getting Bing either to release control to microDot more often while it's processing. I know the Bing's made up of multiple pings that are happening in there, so maybe we can put some sort of sleep in between the various pings that make up the Bing processing, so it doesn't really hold the scheduler locked down for more than 1 or 2 seconds, which will be okay for responsiveness for microDot. I don't really expect a really responsive system, but I don't really want to wait for more than like 5 seconds for a response to come back as well. So we'll see what we can do there. So I'll show you the changes I made to basically the Bing routine to make it more responsive, or at least release control to the microDot web server more often. So up in main, up in the Bing routine here, so I'm calling the Bing routine now with a wait, and that allows me to call an async version of Bing here. So I imported asyncio into the Bing routine, and so I've made Bing async, and inside Bing, this is where it does multiple pings to find out what the bandwidth is. So every time it calls the ping routine, it does it with an on wait, which allows it to pass control while still in the sync down to the get lowest ping. And this is the routine that does multiple pings just to get the lowest ping of a certain sample size. And this is where kind of the magic happens with the sync. So down here, when it calls this, I've put it in a wait sleep half a second after every ping. So this is the bit that's going to release control back to a sync and allow microDot to get some time to process the web requests coming in. And because this is happening all the way through the Bing routine, so it's doing lots of different get lowest pings all the way through the Bing routine, it's releasing control lots of times during the Bing. So rather than Bing just holding the processor for 25 seconds or so, it's now split into probably a whole bunch of 1 second processing, then releasing control with this asyncio sleep. By calling all these things with a wait down here, it will block on that until it gets the response from down here, until this releases control. So it still acts as though it's just a synchronous process by using the await keyword in there. So that's the first thing I did. The other thing I did was down up in main for microDot. I thought the other good thing I could do is if someone comes in with web requests, which isn't going to happen too often with this net logger. Most of the time it'll just be doing the testing of the network. But if someone comes in with a web request, it means we probably want to give priority to them and maybe stop the background tests while someone's using it. So the way I did this was down in this microDot function here before request, it sets the skip test timestamp. So it just sets it to a time that's 60 seconds in the future. And what this will do is up in the scheduler, it now has another test here before it decides to run any of the network tests, to say only do the network tests if the skip timestamp is in the past. So for 60 seconds after every web request, then basically it won't be doing the scheduler tasks, which means the microDot and the web services will get dedicated access to the processor and everything. There won't be any web tests going on or any network tests going on at all, at least for 60 seconds. And every time someone does a new web request, it's going to keep that updating the skip test timestamp, so it blocks the scheduled testing activity for another 60 seconds. And that shouldn't matter for these tests. It's not really time critical that they happen exactly when the plan meant to happen. It doesn't matter if they get delayed, 5 minutes, 10 minutes while someone's using the web interface, and then once they've finished using the web interface, then it's going to get back into doing the normal scheduling with these scheduled tests. So that's the changes I made. Let's test this out, see if it works. Two things here. So on this left side of the screen, I'll have the application. Another thing I put in here is just when the Bing routine's going to run. I just print Bing start, and when it finishes I'll put Bing end so we can see when it's actually in the Bing routine. And then what we'll try and do is click on this and get a web request in while the Bing routine's running, so we can see whether it's been effective if we are releasing the control back to the microDot more often in Bing. So we'll do a hard reset on the device, start it up. Okay, it says Bing started, so let's try doing a web request. So you see the web request came in over here, and we got the results even while the Bing's still processing. So let's just wait for the Bing end to show over here. So that's good, the Bing's ended. So that's the good thing, it shows here that Bing took 31 seconds. So I wouldn't have got this response over here for 31 seconds if didn't have that releasing control down in the Bing routine added in. So let me just do that again. It resets the skip test timestamp to 60 seconds in the future. And what we should see is it just goes through a whole lot of these sleeping. So remember, every time it goes through the scheduler loop, it's going to show this keyword sleeping, but you see it's not doing any tests at the moment because we're still within that 60 seconds. So it's really just giving me dedicated access to a microDot. So we'll just wait 60 seconds until it starts doing tests again. So I know these sleeps are 20 seconds, so next one it should start running the tests again. There we go. So it's doing a Bing again, and let's click on this to see the website's still responsive, which is good. So I think that sort of response time should work okay for me. So the last few things I was doing on the netProbe micropython side of things was I converted a few more libraries over to mpy just to further reduce the amount of fragmentation that happens in the heap. These were fairly small libraries, the uping, ubing libraries, so I don't know whether it's going to make a lot of difference. And then as I went through it and was working on things, I was cleaning things up, so I reduced the number of print statements and things in it, and added some conditional debugging and things. But the main thing I wanted to do was just get some of the final web services going. So we saw the history, start, ID and type one, but I wanted to get this one in place, the host status. So basically retrieve information about all the hosts and their current testing status, so that I could show that on the main page of my Angular application. Originally I was going to go through for each host, go back in the history logs and find out what their last ping, Bing and web results were. And then I thought there's probably a simpler way, and that actually turned out to be just extend my host's test information in that's held in memory. So I added to the host tests object here for each host, as well as having the last ping, bing, and web times. I also added in the last results for those ping, bing, and web as well. So all the information should be there in host tests. Just note that when the Esp32 restarts, that the host tests information is rebuilt, which it's basically doing here, so it won't have any results. But the first thing it does after restarting is retest all the open tests, so pretty much it refills these fairly fast. The way the information gets filled in, again, is up in the main py, so we can see an example here for the web results. It either sets in the host tests the memory information about web tests, either sets it to being false if it failed to do the test. If it's successful doing the test, then puts the various results into properties of the host tests. And got that running at the moment, so let's have a look at that. So this host status request, you can see here it brought back the 3 hosts that I'm currently testing on. The last test times for the various tests, and then the results of those tests as well, and same for all 3. So this will make it easy to, in the Angular application, sort of do a quick table of hosts and tests and results in there. All the information should be in there, and we've still got the history information. See it here for bings for host 3, and it's summarized by day, because I actually changed the parameter, so it's now just 48 hours. If it's less than 48 hours, it shows hourly results. If it's more than 48 hours, it shows daily results. And I think if it's less than 12, it shows all the detailed results. And I'm still sort of tweaking with that. I'm finding that the microDot web service, where it changes objects into JSON, it sometimes has memory errors, memory allocation problems if there's too many results in it. So I'm still sort of tweaking when to summarize at the various stages, so there's not too many individual objects in some of these things. So it works successfully. Let's see what else we got here. Okay, just another one just to find the current host details. So basically I've got all my query type web services put together, so I'll build that in the Angular side of things, and then I've got to think about being able to update this information about hosts as well. So you can change, add hosts, delete hosts, change the things you want to test on those hosts, all from the web application. I haven't got the web services put together for the updates yet. I know I've got the actual functions down in the hosts module, so shouldn't be too hard putting the two together when I do that part. But I'll get just the query side of things going first.